So this lesson is on determining volume. So this is a really interesting thing. It says right here, each side length, diameter, and height of these objects is 1. List them in order from least to greatest volume. It's a really good question. I like this a lot. We have to kind of remember or consider what the formula is for the volume of each of these things. For example, the cube is the easiest one on the list because it's length times width times height. So with that, its volume is just going to be 1, because 1 times 1 times 1 is 1. The cylinder would be pi r squared h. Now it says the diameter is 1. So actually then it would be the radius would be a half. So if the radius is a half, well, that's like a half squared is a quarter. So it'd actually be a quarter times pi times 1. So it would be basically pi divided by 4. So it's actually, this is going to be 0.79 if you work it out. So it's smaller than the cube. Okay, interesting. The sphere, 4/3 pi r cubed. The radius would be a half though. So that would be 0.125 times pi times 4 divided by 3 times pi. It's actually the smallest of anything we've seen so far. It's 0.52. And then if we look at the cone, well, that's 1, but that's 0.5. So it's 0.25 times pi times 1. That's actually going to be the same. Isn't that neat? It's actually going to have the exact, whoa. No, that's not right, because then you have to divide it by 3. Ooh, that's bad. Divided by 3, yeah, it's not even close, actually. It's actually going to be 0.26. So it's by far the smallest so far. And then we have a pyramid, 1, 1, but then it's a third. So it's like a third, which would be 0.33. So what we see from this is, if I rank them from 1 to 5, with 1 being the smallest and 5 being the biggest, of course the cone would be the smallest, pyramid would be the next smallest, sphere would be right in the middle, cylinder would be the second from the best, and the cube would be the biggest of all of them. So the cube is the biggest of all of them. Cool. I like that little exercise where we just say everything is 1. How do these shapes relate? And that's what we would get. The cone would be the smallest. The pyramid would be the next smallest. And that makes sense because there's a lot of wasted space when you have all those parts coming together into a single point. The sphere would be the next smallest, which also makes sense because there's round parts that are, again, there's a waste of space. And then you have the cylinder, and the cube is the biggest of them all. All right, got a couple examples. Let's get to them. A cylindrical cupcake is baked. There's a hole in the middle that is also in the shape of a cylinder. What's the volume of the cupcake? Okay, what's the volume of the cupcake? This question's a lot like the Toonie question from your last assignment. So what we're trying to do is we're trying to find the volume of the cupcake. So we're going to first pretend like there's no middle being cut out. Okay? We're going to first pretend there's no middle being cut out, and we're going to find the volume of the entire thing. That's how we're going to start this. So the volume of I'm going to just put volume whole is pi r squared h The radius, given that this is 15, is half of that. So it's 7.5 squared. The height is 9. So we're going to get 7.5 squared times 9 times pi. And we're going to get 1,590.43 centimeters cubed. That's the whole thing with the center intact. We can kind of think of this as taking a cylinder like this, but with no ends on it, and think of me just taking this and like cutting a middle piece out of the cylinder. Because now I want us to find the volume of the inside of the cylinder, just the inside. So of course that is a cylinder. So I'm going to go volume of the inside. It's the same formula. It's pi r squared h. The radius now, though, is half of 4, so it's 2. And the height is still 9. So 2 squared is 4. So that's 36 times pi, which is 113.10 centimeters cubed. So now that we found the volume of the inside, we can find the volume of the cupcake by just subtracting these volumes. So 1,590.43 minus 113.10. And that's going to be 1477.33 centimeters cubed. That is the volume of the cupcake. Okay, so here we go. Jaden wants to measure the volume of the hand-in basket. Would he use cubic centimeters, cubic meters, cubic feet, or cubic inches? Which one do you think he would use? Which one of those units do you think makes the most sense? So, we have determined in our discussion that cubic inches is probably the best response. And to explain why, probably a good way of doing that would say cubic centimeters are too small and cubic feet and meters are both way too big. So it really just comes down to cubic inches are probably the best unit to use because we'll get a good number of them, but not like a crazy high number of them like we would with cubic centimeters. So cubic inches is probably going to be the best response for that one. And that leaves us with one last example. We have a cone here, and the cone has a radius of 40 centimeters and a height of 1.2 meters. Part A says, should we use, when we figure out the volume, should we use cubic centimeters or cubic meters? In other words, should we turn the meters to centimeters, or should we turn the centimeters to meters? to kind of think about that, let's think about the formula is for the volume of a cone. Volume of a cone is pi r squared h. So you're going to be squaring the radius, and then you're going to multiply it by the height. And actually, I got to put that third in there. Forgot about the third. Then we're going to multiply it by pi. So if you do this, it's going to be 40 times 40, 1600, times 1.2. That seems like it gets really big, really fast. And actually, if we kept this as, if we did in centimeters, we'd have to turn this into centimeters. So then we'd be multiplying 1600 by 120, and we get a massive, massive, massive big number. So probably centimeters is not the way to go. So we should probably use meters. So meters cubed would probably be the safe way to go for this question because the numbers wouldn't get too crazy. And now we have to go and figure out the volume. But before we do that, we got to turn this into meters. So we know that there's 100 centimeters in a meter. And if we have 40 centimeters, that's 0.4 meters. And we get that by taking 40 and dividing it by 100. Now, just substitute in the radius and the height, and let's figure out the volume. Pi, radius is 0.4 squared, height is 1.2. Now, I'm going to warn you, we are going to get a fairly small number here as our answer, but I think that's a little bit better than getting a massively big number like we would have if we would have stayed in centimeters. So we're going to have 0.16 times 1.2 times pi times, actually divided by 3. So we actually get the volume is 0.20 meters cubed. Now, roughly speaking, that would have been over 200,000 cubic centimeters. That's huge. Big, 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 big. So, we might be like, well, that's a really small number. It's like less than 1. Maybe we should have used centimeters. Well, maybe, but then we'd be over 200,000. So, considering all things, I think that meters cubed is the most appropriate unit to use here because the numbers don't get too crazy and too big.